Okay, this is our video for the Chapter 2 practice test in statistics. We are looking at questions 7 through 9 in this short video. So let's hit me over there. Okay, so the length of pregnancies from conception to natural birth among a certain female population is normally distributed random variable with a mean of 270 and a standard deviation of 10. Normally distributed is extremely important here. And if you think I'm going to go to the curve followed by a z-score followed by an answer, you're absolutely right. That's exactly what we're going to do here. So let's take a look at a normal curve. So not knowing exactly where the next question is going to take me, I've gone ahead and, as normal, put the z-scores above the curve with the notation n01, and below the curve I put the contextual data with the normal distribution, mean of 270, standard deviation of 10. So now let's take a look at question A. Oh, question A is not here in front of us. Let's see if we can find it. So it turns out I didn't even put my normal curve where it needs to be because I don't have 300 on my normal curve, or I don't have any numbers close to 300. 300 is on the far right of the curve, and if you've been looking at a normal curve for a little while now, you can tell that the area above a z-score of 3 would be close to 0. So, you know, there's not even a whole lot to shade here. I'd have to shade just this little portion right over here. I mean, that's nothing. There's no area there, or there's barely any area there. So we're going to expect a small number. If you wanted to compute this with the 68, 95, 99, 7 rule, absolutely feel free to do that. I'm going to look at the normal calculator with my TI-84. Now the first thing I'm going to do is calculate the area using z-scores. And if you remember from our curve here, the left side of our shaded region has a z-score of 3. So we'll put a 3 here for our lower. And since the z-curve goes on infinitely, we can put a really large number here. If you put 1,000,000 here, that's fine. But I usually just will put the largest number my calculator will hold, which was 1 EE99, which would be 1 times 10 to the 99th power. Because I'm in z-scores, I'll leave that at 0 and 1, and we'll paste that, giving me an area of 0.0013. Let's do this exact same thing, but in context. So in context, we are going to go back to the normal CDF, and our lower is 300 days, I think it was, and upper, there really is no upper limit again, so I'm going to keep that at 1E99. But this time I'm going to change the mean and standard deviation to relate to this problem. So mean and standard deviation for pregnancies is 270 and 10. So the mean is 270, standard deviation is 10, and we should get a result that's really close. And yeah, that's pretty spot on, I would say, 0013. We've got a couple of things to do here. We're going to write down in terms of z-scores, proportion on the z-curve that's greater than 3 is equal to 0.0013. Also, the proportion of pregnancies, in context now, that's greater than 300 is also equal to 0.0013. We didn't put down the z-score conversion, so we really should do that. The z-score is equal to 300 minus the mean of 270 divided by the standard deviation of 10. So that's going to equal to 3. And if you're wondering, this 3 is why this is a 3 here. Now that we have all of our calculations out of the way, we're going to write our summary. So about 0.13% of pregnancies last more than 300 days. So just to note to you again the things that we have done. We've got our z-curve here. We've got our z calculation right here. We've got probability statements right here. We've got our summary right there. So that's everything that you could possibly want for this, and we'll move on to the second question. Let's get our normal curve into the picture here. I've gone ahead and I've labeled the top part with z-scores, the bottom part with contextual data, and then now we're going to say the shortest 10% of pregnancies. And if you have some sense of the data, you might know by now that we're really talking about something between a z-score of -1 and -2. Okay? And shortest 10%, so this area here is 0.1. So we're saying we don't know what the z-score is, so we're going to say our z-score is equal to, and we're going to leave a blank here for the height, or sorry, for the length, minus 270 over 10, and that's going to be equal to our z-score. And then the next thing we're going to write is our proportion statements. So pregnancies, no, let's do z-scores first. Z-score is less than. We don't know what that z-score is, but we know that that proportion is 0.1. We can do the same thing with the pregnancy. Shorter than, and we know that that's equal to 0.10. Little color adjustment here, and when I'm looking at this now, there's really only two numbers that I need to fill in because everything else is already known to me, and I'm going to get those two numbers based on my z-score calculator, my inverse norm, because I know the percentile rank is 0.1 and I want to go back to a z-score or a pregnancy. So we'll get to our calculator and we'll go to the appropriate function, which is the inverse norm calculator. And we'll do this twice. We know the percentile, nope, that's the wrong one. Well, apparently I'm all crossed up here. Let's start all over again, and we'll go to second, vars. Number 3 is our inverse norm calculator. We know the area is 0.1. We're going to do the z-score first. That's 0, 1, paste. That gives me a z-score of -1.28. Let's get back over here. And our z-score is -1.28. Okay. Next, we're going to do this same operation, but we're going to do this in context. So in context, we have area still 0.1, but we know that the mean pregnancy is 270. No, it's 300. 300? Something tells me that, no, yeah, it's 270. Little bit of adjustment here. We know the mean is 270 and the standard deviation is 10. So 270 and 10. And that gives us a pregnancy lasting 257.2 days. 257.2. And we'll go ahead and write that in our blue blanks. 257.2. 257.2. And then the last thing we're going to need is our summary statement. So a pregnancy must be shorter than 257.2 days to fall in the shortest 10% of all pregnancies. So notice, again, with the work that we're showing, we got a z-curve, a normal curve, we've got a z-score calculation, we've got our probability, and we've got our summary statement. So that should suffice. Let's take a look at our next question. This is kind of a 2-for-1 question. So question 8, which is true for this density curve over here? Is the density curve symmetric? Yes, it is. Which means it's not skewed right. Which means it's not skewed left. Is it normal? And no, it's not normal. Remember, a normal curve has those points of inflection right here and here. This has no points of inflection at all. So this is not a normal curve. So the only one that's correct is letter A. This is a symmetric curve. And question 9, which should be a little bit easier, is what are the approximate mean and median? Well, if we just said it's symmetric, the mean and median should be right in the middle, or the line of symmetry, which is 0.5. So the mean is about equal to the median. Really, it's exactly equal here, and that's equal to 0.5. So hopefully that helped you. Again, that was questions 7, 8, and 9 from your practice test. We'll see you for the next video.